Ansys ACT Toolkit allows users to automate simulation processes with the creation of guided processes such as a simulation wizard. Using a simulation wizard can be very powerful to automate tasks in pre- and post-processing, to ensure different people in the organization will set up the same kind of analysis the same way, to involve new people in simulation by training new users more easily, by ensuring new users will make the proper choices and assumptions. As part of an ACT extension, a wizard needs some programming to be created, which may be time-consuming and not straightforward for FEA analysts such as you and me. With the automatic wizard creator, there is no need to write code anymore. Based on a template simulation, you can create a new simulation wizard in a few seconds. That's what I am going to show you in this video. First, open a template project. Then go to the ACT Start page to launch the App Wizard extension to be able to use the automatic wizard creator. Before going further, you can add a new extension folder to be taken into account when generating the new wizard. Go back to the project page and open the template simulation in Mechanical. Here we have a pump assembly of different parts with various material properties. Some coordinate systems are created and may be used for post-processing. Mesh controls were defined, as well as one named selection. Our analysis of interest is a two-step static structural analysis with the following settings. It has three kinds of support. A thermal condition on the housing body, an internal pressure in the pump, a bearing load along the global y-axis is applied in step 1. There is also an actual remote displacement on the top of the shaft. As for the results, some are asked on the whole assembly and others are scoped to specific parts only. As the simulation wizard to be created will use the current object's name, it is strongly advised to rename objects properly, with self-explaining names so that the end user will understand what he is asked to do. This is what we have done here. When it is done, click on Open Wizard to make the wizard panel appear and then launch the automatic wizard creator. If docked in the right-hand side of the graphical window, you may not be able to see clearly everything. If you have two monitors, you can take advantage of the two screens by undocking the wizard so that you can see properly the model and the wizard as well. Filling the information for the wizard definition is quite straightforward. Give it a name, choose a directory where to generate it, browse for a picture to appear on the upper left-hand side of the wizard as its icon, put your name as the author, and give a short description of what the wizard is supposed to do. Then choose the template analysis you want to build the wizard upon. In the wizard features, select the object to be taken into account by the wizard. When ready, click on the next button at the bottom to go to next step. At this point, the first thing to do is to read the feedback given by the automatic wizard creator. After that, decide what to do with the created extension that contains the wizard. You can encrypt it in a binary format to forward it to other users, have it installed and loaded so that you can test it. When you have made your choices, click on Finish to exit the wizard. Back in the project page, the previously selected actions now be launched by clicking on the dedicated toolbar button. After a few seconds, you will get some more details of what was accomplished in the background. That's it. The wizard has been created. Now on this new project, launch again the ACT Start page. In the Extension Manager, you can see that our extension is already loaded. Clicking on About will display the information that was automatically associated to the extension based on the definition input in step 1. You can also open a window explorer in the extension directory and you will see the structure of the new extension. Now let's use the created wizard to discover how it works. It is a mixed wizard, meaning that it starts in the project page by asking some basic user inputs such as the project name, the location where it will be saved, and of course the CAD file we are going to work on. You can filter by the CAD type. By default, it will create a system with the material library exported from the template simulation. Clicking on Next, create the desired analysis system with the template simulation name and open Mechanical with the CAD file imported. Again, it can be useful to undock the wizard and take advantage of a second display if possible. The first thing to do is to create all the named selections that will be used to automatically define the exported features such as mesh sizings, loads, and boundary conditions and results. Here you can see that some of them were already defined and the wizard has already recognized them. So let's just select what is missing. When everything is ready, click on the Next button. Here, the next step is to assign materials and thicknesses on surface bodies, which is automatically done by answering yes to the question ready to assign materials and thicknesses. If it is correct, click on Next to proceed further. The next features to be automatically created are the coordinate systems. They are exactly the same as the template simulation. Click on Next after a sanity check. We are now in the mesh settings definition. First, click on Yes to apply local mesh sizings. Again, the same values as the template simulation are used. If some of the local mesh controls are not taken into account by the wizard, they are mentioned in the notes and the user can define them manually. Under Mesh Generation, decide whether or not you want the mesh to be generated before going to the next step. Clicking on Next will apply the same global parameters as the template simulation, which values are set by default in the wizard interface. Of course, they could be changed by the user. Moving forward, it is now time to apply the analysis settings. Like previous step, all default settings values are the ones extracted from the template simulation. Click on Next when you are OK with the user input to proceed with the loading conditions. Here, the wizard is awaiting for some values for the loads, which magnitude needs to be defined. To do so, just click on the Edit button and fill the desired tables. The time column is already pre-filled with the load steps and times. Like in the mesh settings step, if some loads and BCS were left behind, they are mentioned in the Help section. After clicking on Next, you can double-check what has been automatically done. The names of the template simulation loading have been reused, so that it may be relevant to have them renamed properly before generating the wizard. Now it's time to define standard results by answering yes to the question that is asked by the wizard. By default, only supported results will be added automatically. At this point, the simulation looks pretty much the same as the template one. A final step has been added to make sure some sanity checks are made and to ensure that the user will handle the contact regions between the parts of the assembly. If you want to close the wizard, click on Exit and then proceed to the contact regions definition. Whether or not you can rely on the automatic contact generation, it may be more or less straightforward. After everything is done and checks are made, comes the solve time and the post-processing. Using the wizard actually minimizes the time of pre- and post-processing, with standardizing the way the analysis is set up. I hope this demonstration has convinced you to use the automatic wizard creator, which is the best solution to get a reusable simulation wizard that you can enhance the way you want within only a few clicks.